Okay, so we are live now. So we were solving LRU cache problem. So we need to implement three functions: deattach and add at start, which will be in get function, and in put function also. And we also need to remove least recent node in the case our capacity reaches a certain threshold, and also we need to implement a function add to start. So let's implement these functions. So first let's just implement this function. Okay, so we have a list node. So we need to remove this list node from its current position, and we need to attach it at the start of the list. At the start of the list. Okay. So first we'll find this node's previous node, which will be node dot previous, and this node's next node, which will be okay. So we need to move its previous node to previous node's next pointer to uh, the next node, and next nodes, if our next node is not equal to null, in that case we need to move our next node's previous pointer. So our previous node can't be null because we are having a dummy node which will be always present at the I can say end of the list. So that's why previous node will always be present. So next dot previous node we will be marking as the previous node. Okay. Now for the current node we will make its next value as null and its previous value as null. Okay, so now what we'll do, we will add this node to the start. So what will we do, we'll call our add to start function, and we will add this node at the start. Okay, so now we will implement our add to start function. So in add to start function, we take a list node which we need to add at the start of the list. So our head pointer will be present at the start of the list. So what we will do, we will make our head dot next as node, and node dot previous as head, and we will move our head pointer to next pointer. So this is how we add a node at the start. Okay, so we have implemented this function. Okay, add to start, and basically this is a deattach function. We will deattach and then we will add to start. Okay, so basically we have implemented this function. Now we need to implement this function, remove a least recent node. So least recent node will be present at the list's next pointer. So that will be our least recent node. So what we're gonna do here is we will initialize our function, list, remove list recent node. And now what we'll do is, so our list pointer will be present at the end of the list. So we will remove the node present next to it. So what we will do here is we will make first we will find the node which we need to remove. So sorry, this is our double list. So wherever I am using this, I need to change it with double list. Okay. Okay. So to remove list recent node, so my list recent node will be the node present next to it. So basically we need to remove this node. So in order to remove this node, what we'll do, we will point list's next pointer to, okay, if our list, let's say this node is null, then we don't have any node in our system, so we will simply return. Otherwise we will make it its next pointer, to list recent nodes next pointer, and this node's previous pointer to list stored next. Stored next is the list recent nodes next. Okay. If my this node is not null, in that case I'll make its previous pointer to list. And to completely remove this list recent node, I will make it next pointer as null and its previous pointer as null. So add most recent node. Okay. Remove list recent node. Okay. So, so these are the three functions. I think we can give it a chance by running. Okay, so there is a syntax error. Okay, so we only have a value in our list. So okay, we are getting a null pointer exception here. Okay. So initially my list have a -1 value, which is the dummy node, and then I call the put function. So after that my list has one value. Then I again call the put variable. So my list now has two value also. Now I call get value. So I'm calling get on one. So what I'll do is I will make one as the most recent node. Okay, this is also correct. Now I'm making a put call. I'm putting three. So I think our capacity. So our capacity is two. So putting three will make capacity three. So we need to remove the most least recent node. So we will first remove two node. Okay, we have removed. Then we have added three node. Okay. Then what I'm doing here is put, then I'm calling get function on two. Okay. So I think if I'm removing least recent node, then I also need to remove it from the map. Okay, so how I can remove a node from the map? So for that I need key for that node. Okay, so in this function, when I am removing the least recent node, I also need to remove that node from the map also. In order to remove it from the map, I need a key variable. Okay, but I'm only storing a value of the node in double list. Okay, so we need to modify our double list in order to store the key. Okay, so I think we need to modify our double list. We need to add a variable key here. Let's define key. This dot key is key. Okay, value. This is value. This is key. Let's make it key and value. Okay, so initially we will put both key and value as -1. Okay, so remove least recent node. So I need to check wherever I am creating a node. So here I am also creating a node. So I need to put a key and value. Okay, okay, so now I have a key for the node which I will be removing. So I will define my key here as least recent nodes key. Okay, so now I have key for my least recent node, and I will remove that key from the map also. So map dot remove that key. Okay, so I think this should work. Okay, we are getting 0 everywhere. So this is my key, this is my value. City handling list. Okay. So if my map contains that key, I will find that node and will detach from start and add at the end. Okay, so this is my value. New node key and value. Okay, I think here we are getting a issue. So we are passing key and value. Okay, so to our double list. So we have key and value. Okay, so this should be val. Okay, so our case is running, test case is passing. So I think uh, I should comment this print part and once try to submit this. Okay, okay, we have our own submission. I think we again need to have that print statements. Okay, let's use this test case and try printing our list. Okay, so my capacity is 1, so I will put the key number 2 with the value 1. Okay, so value 1. So basically I'm printing value here, so that is why we are getting value here. Then we are getting calling get function for the 2, means against key number second. Okay, so here we are calling a key function. So our map in map key is present. So basically while deattaching our node, we have removed our node. So I think this function is not working as expected. So suppose my list is something like this is my this pointer and this is one pointer. So when I'm calling this remove node, this node, so I'm checking its previous node which is -1. It doesn't have any next node. So what I'm doing is I'm making previous dot next as the null. Okay, means I'm making this as the null, and if my next is not null, but here next will be null, so I am skipping this part. I'm making my node dot next variable to null and previous variable to null. Okay, so now I have this node. Okay, so what I will do now is I will okay, so here my head pointer is getting manipulated, so I also need to take care of my head pointer. So basically this is my head pointer, so my head pointer will remain here. So what I will do in that case is I will make my head dot next as node. Okay, and node dot previous value as head. Okay, so in this case I need to, I can do one thing, that is if my node dot next is null, this means this node is already present at the start of the list. Then in that case also I can return. So here I'm not removing my node. So after calling get, okay, then I'm calling put operation. Putting 3 into the map. So I'm calling get on the 2. Okay, so I have removed the 2. Okay, then I'm calling get on the 3. But I don't have 3 in my list, so how I'm getting a value 2? I think I also need to figure out logic for this. Okay, so suppose -1 and 3, 1 are present. So I reach this condition, my capacity is not 0, then my capacity reaches 0. Okay, then I'm again calling put function, then my capacity is already 0. So what I will do, I will increase my, after removal I will increase my capacity. Okay, so I will call remove most recent node. Remove least recent node. Okay, so if my least recent node becomes equal to head, then in that case also I'm sure that I need to modify my head. Means I need to move my head to the previous position. So let's see, least recent node. If my head is least recent node, then in that case, I will move my head pointer to list pointer. I can also call list pointer as the tail. Okay, so now we are getting to here. So this was a edge case when my list node is at head. Okay, here also we have tackled a case. Where was it? Okay. If only one node is present, so in that case also. So I think we can reset our test case and check whether previous test case is breaking or not. Okay, so let's try submitting this code. I think we need to remove the print statement. Wait a second. DT. Okay, so I have removed all the statements and try submitting for this test case for which we have got TLE. Okay, so it's running. Let's try submitting this code. Okay, we have a pretty fast solution, but our solution is pretty lengthy. So this solution can is not a good solution from the perspective of object oriented programming because these functions which are add to start and deattach, we need to implement these inside our double list class. So that is how this will separately handle its function. So we can also do that. So suppose we move these functions, these helper functions 1 2 and 3 inside our double list class. Okay, so wait a second. We have moved our functions inside this class, and instead of okay, I think GPT can help us to decide what's the better oops implementation. Okay, Okay, move to front. Move to front. So move to front. So that's what I was saying. We can move our these functions inside the list. So W list, cache list. Okay, so this is a good approach to handle the edge cases. We have also defined a tail node, a dummy tail node. So I think this is a good approach. We are adding in between this tail node and head node. Okay, so this is a good solution. Okay, so we have completed our linked list part, and today we will start with the trees. So I think today we can solve these three easy problems and then these three medium problems, or we can solve these. Okay, we can solve these four easy problems and these three medium problems. Okay. Okay, so we can start with the trees. Binary trees basically. So binary trees are trees which have at most two childrens. Means the tree in which every node can have at most two children. So that are called binary trees. Okay, so first question is invert the binary tree. So given a root of binary tree, invert the tree and return its root. Okay. So inverting a tree means suppose this is our root and this is its left part. So after inversion, its left part become its right part, and its right part have become its left part. And similarly for the rest of the tree. So basically, most of the tree problems we will be solving with recursion. Let's see. So okay, I need a charger. Wait a second. So let's transfer this tree recursively. So if our root is null, we will return null. Let's move to the left subtree, which is root dot left. Let's transfer its right part. Okay. So what left part will do is it will go here, here, and at the end it will have nothing. So it will move to this part. Okay, so then it will be backtrack and again reach to root. So now when we have reached to root, so after end of this recursion we will be here. So what we need to do here is we need a temporary variable. Okay, so in which suppose we store this right node. What's the right node? That will be root dot right. Okay, let's call it temporary variable. Okay, so we have stored our right part. So now we will in place of right part we will put our roots left part, and in roots left part we will move our temp. Okay, and at the end we will return our root. So I think that will work. Let's run this. Okay, let's submit this. Okay, so we have submission. So my last submission was in 22. So I think that would be also same. Okay, same solution, exact same copy. I think I should have looked a way where I can solve it using only using the iterative way. I think we can try it doing in iterative way also. Means without using recursion, because recursion is using stack, and in iterative way I will also be using stack. So let's see if we can solve it in a iterative way. How we can solve it iteratively? We can have a stack, and in that stack we need to add elements, left part of a root and right part of a root. Given a root of a binary tree, invert the tree and return its root. So return its root. Suppose I use a stack here, and in that stack, first I need to put the left part while I don't. I think we can look for a solution from GPT. Let's command C, provide a iterative solution. Okay, so the iterative here is the iterative solution for inverting a binary tree using a stack depth first search approach, DFS. Okay, so we have initialized a stack and we have pushed the root into it. So while our stack is not empty, we will pop our current element. and we will change the directions. Then we will move left part to the stack, then right part to the stack. Okay, understood. It was pretty easy. We need to focus, guys. Handle base case, start with the root node. Okay, we need to handle base case also. Okay, maximum depth of a binary tree is the next question. I have accidentally closed the tab. So, okay, wait a second, guys. This tree, move to here, move to the sheet, move to this part, practice. Move to here, we were here, and this question we have opened it in a tab. So, given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf. So, basically, the uh, this tree has a three uh, maximum depth is three, one, two, three. So we need to return the maximum depth of a tree. So this also we can do recursively. Suppose we are here on the left part. Wait a second, guys, wait a second, wait a second. We are here on the left part. So we will return maximum of these two nodes, which will be one here. And now we will return one plus this here and one plus this here. 1 plus 0 here, 1 plus 0 here. I will take max and 1 plus here. Okay, so see, like similar, previous to similar question. If my root is null, so root is null. In that case, I can return 0. Otherwise, suppose I transfer to the left part. Okay, I will find depth of the left part. Then I will find depth of the right part. Root dot right part and my depth total depth will be 1 plus maximum of depth of left part and right part. So I think this will work. Okay, so this is working. We can submit it. Okay, we have a submission. We can also do it iteratively using a stack. Let's see solutions of other people. Let's ask from GPT the iterative way. So I think iterative way in iterative way we can put the element to stack. We can initialize a stack and put our root node into the stack. Okay. So after that, we can move to its left part or its right part. Here's the Java version. So we have a root, we have a stack of tree node, we have another stack, depth stack. Max depth is 0, depth is 1. Okay, while my node is not null and my stack node stack is not empty. If my node is not null, then what I will do is I will move node to my this stack and depth stack also. Okay, and go to my left side and increase my depth part. Okay, else if my node is null. Okay, moving to left initially. So I think we should take an example. So here's our solution and here's our description. Where's the Java part we were doing? Yes, this is the question. So initially our node is 3, our these stacks are empty, our depth is 1. So if our node is not equal to null, we will push node and depth to their respective stacks and move to this part and increase our depth. Again, we will for to this loop and will increment our depth and we'll add 2 to the stack and now this depth has become 3. Okay, now when you come here we see that our node is null, so now we will check. Now our stack is not empty. Our stack has 9 at top and 3 at bottom. So we will pop from our stack. So now we have 9 here and depth will be 2. So our depth is greater than 0. So our max v becomes 9, sorry 2. We'll move to right of the 9. So it doesn't have anything on the right. So now we'll again increase our depth. Right of 9. Depth will become, okay, so here my depth was 2. Depth will become 3. But right part is null. So again I will move to this part and my depth again becomes 1. Now I'll move to this part. Depth becomes 2 and move to this part. Okay, while my node is not null, I will move to the left part, and when my node becomes null, I will pop a node and move to the right part. Okay, so basically this is I think we should also learn iterative ways of in order, pre-order, and post-order transversals. Okay, so this is I think iterative in order transversal. Okay, so we need to implement iterative in order, pre-order, and post-order solutions. Tinku Foda. Can you give me quick update on any API of that transaction? GetGives API? Currently, there's no update. Actually, previous week I was waiting for you to come over my place, so you didn't come, so I don't have any update as of now. Okay, actually, the previous week I got busy in something. Okay, no issues. Actually, it'll take me 30 minutes. So actually, I have a lot of time during end of the year. I am on a 7 day vacation, so it will not because I had leave balance left. Yeah, mandatory leaves, bro. Oh, mandatory. Okay. Okay. Actually, I got shifted to project earlier in training mode. Okay, so tomorrow we will be solving uh, means tree questions iteratively. Means first we will be looking for the approach of these transversal. So basically we have three tree transversal. First one is pre-order transversal. Uh, then we have in pre-order transversal we print left part first, then root, then right part. Okay, then we have post order transversal. In that we first print right part, then root, then left part. And in order transversal we will first print the left part, then root, sorry, the root first and the left part, then right part. I think that's the transversal. So we will be implementing these three transversals iteratively. That will help us. So basically interview can ask us a question and on a tree which can be solved easily with recursion, and also he or she can ask us to solve the question uh, in a iterative way. So we need to get ready for both types. Okay, so let's solve a diameter of a tree, binary tree. Given a root of a binary tree, return the length of the diameter of the tree. Diameter of a binary tree is the length of the longest path between any two nodes of the tree. The path may or may not pass through the root. Okay. The length of the path between represented by the okay. So I think diameter here refers to, suppose I am at a root x root, and uh, adding the left part means max left on the left part and max depth on the right part. Okay, so here I suppose for this node I have two on the right path and one on the left part, and after adding it, the three is the diameter of, so basically this edge and this edge forms the maximum diameter of the binary tree. Okay, suppose I am suppose my root is null. So if my root is null, in that case I need to return null. So, but if let's iterate a right part, diameter of I can just copy it here, diameter of a binary tree, and root dot left part. Similarly for right part. Okay, so I'm transversing both parts. So for this node, what I need to return is I need to return max. Suppose I was at this node, I need to return max number of node on the left side and max of on the right side. So here suppose I have one node, here I have one node, then I reach this situation and I check here that this node has one node on the right, this node has a one node on the right. So in the case of 0, I will return 0, 0. 1 plus max node on the right. Okay, so let's say this is my left part. Uh, this is my right part. So when I reach null, I will return 0. Suppose I have a variable max value, max depth. That would be left part plus right part's sum. And if I reach this part, so to the above node, what I will gonna return is I will be returning return 1 plus max dot max of left part and right part. So I think I need another function. Suppose I call this util function and call that util function root, and after that util function I have some value in my max depth and I can just cut it from here. And public int util function which takes a root node, and I can define it like something like this. So let's try run our code for this function. So we are passing root. Okay, we are checking root is not null. So then we'll recursively call left function and we will reach here. And we will check if left part, we will call left part which will return 0. We'll call right part which will return 0. So max depth will be 0 and left part plus right part will be 0. So we have called this function for 4. Okay, function is called for, it will return 1 Okay, 1 and called for right will return 1, and for this root part 2, max depth becomes this and this, max diameter basically. I think this will work. Okay, so okay, how we can solve this also iteratively. Okay, so I think tomorrow we will solve these three problems iteratively first, and then pre-order and remaining transversals, and then these three easy problems. I think that is it for today. Thank you guys.